All right, so last day of practice for this midterm. Again, we're going to do 7 problems today, and this is going to be like the rest of the stuff that's on the test. Again, just because I'm doing 23 problems doesn't mean there's only 23 problems on the test. There's anywhere from 36 to 38. I keep forgetting to check. I'll check before you guys leave today. But there will be repeats, right? So this might look like a repeat, number 17 and 18. It is the same idea, but they're not the same type of problem, okay? So for number 17, you're supposed to rewrite this. Now, I'm just going to remind you, x to the a over b is the same as radical x. B is the index. A is your power. Okay? So this one becomes a 16 inside, 4th root to the 3rd. Okay? Well, the 4th root of 16, so a number that you multiply times itself to get 16 4 times would be 2 times 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. That's 4 times the same number. So the 4th root of 16 is 2, and 2 to the 3rd is 8. Again, people ask me, well, if my calculator can do this, can I just do it on my calculator? Sure, but not everybody's calculator can do this. And some of you guys, you don't know how to use the calculator to do this, right? And I can't be like tutoring you during a test, right? So if you don't know how to do it, make sure you know how to break it down, okay? And if you want, before the test starts, if you want me to reset your calculator to its default mode, just come see me before you get started. Those of you guys with the black calculators that I let you use, I can have you guys all do it at once together. Okay, I wouldn't have to do everybody's. But if you have a different one than the ones I use, just let me see it and I'll clear the memory for you. Because sometimes your calculator can do cool stuff like this, but you've changed it to like decimal forms and all this other stuff. And now all of a sudden it's in the wrong mode to do this other type of math. So just let me know if you want. Okay, I can clear it out for you. And then from there you can see if it actually works. So, all right, 8 to the 5/3. So same thing. 5 is the power, 3 is the index, right? So this is going to be radical 8, index of 3, power of 5. Well, the cubed root of 8 is also 2, right? The 4th root of 16 was 2. The cubed root of 8 is 2. Because 2 times 2 is 4, times 2 is 8. So that's my cubed root. And it's 2 to the 5th. 2 to the 5th power is 32. Okay? These are easy problems. Right? They're easy problems. They don't require a lot of work, and in some cases, you just got to punch in some stuff into your calculator. But if you're not sure, if I were you, I would work this out, and then I double check with my calculator to make sure. Okay? But there you go. All right, negative power. So remember, a negative power, you got to flip it upside down, right? So if you have like x to the negative a, there's 2 ways you can do it. You can either write it like this, 1 over x to the a, which is the more preferred method. Or you can write it as 1 over x all to the power of a, which is sometimes useful for specific things. But most people will use the first definition, okay, 1 over x to the a. Notice the a term was negative. It becomes positive once I move it, right? So this right here is going to become 1 over, and this is, I'll write it this way, 3x to the 6 to the 1/3. Remember, the 1/3 follows it. It just becomes positive. Now, a 1/3 power is a cubed root, and the power of 1 doesn't matter, right? It's not going to do anything to the problem, but I'll write it there. But this is a cubed root of 3x to the 6th, all to the 1st power. Okay? So, the 1st power doesn't matter, just do the inside. The cubed root of 3 does not exist, right? The cubed root of 1 we know, the cubed root of 8 we know, the cubed root of 27, of 64, of 125. There is no cube root of 3. So, but I do know x to the 6th, I can break that down, right? So that's going to be 1 over cubed root of 3, x cubed. All right. Since the index matches the cubed powers, let me kind of highlight that really quick. Then those are able to come out. So your answer will be 1 over x squared cubed root of 3. Now the reason why I'm not going to rationalize this is because I'm pretty sure, if I remember correctly, when I saw one of these problems, you're not going to end up with the radical on the bottom. So I'm not going to make us do that because that's not going to probably happen unless somebody changes. So I got to look today. But I'm pretty sure you're not going to end up with the radical in there. Okay? So, I mean, just move it down, simplify. That's all. All right, so we've passed all the powers problems. Now we're just going to start doing radicals. Okay? Remember, the way you get rid of radicals is by squaring things. And the thing that I told you guys, and I'm going to put it right here, and again, this is something for you maybe to write in your notes in case you kind of forget how to do this. You want to isolate the radical. Isolate the radical. In other words, make sure it's only the square root of something on one side, okay? Make sure it doesn't say like the square root of 12 minus n plus 5 equals n. Like, don't do that. If it says plus 5, then move it out of the way, okay? Get rid of it. You want the square root to be all by itself, okay? So that's the way this one looks like. Number 20, the square root is just hanging out by itself on the left side. So let's square both sides, okay? So this becomes square root of 12 minus n squared equals to n squared. Now I want to remind you guys, when you solve these things, a lot of times you end up having to use the x method eventually because you got to solve for specific solutions, and you got to check your work to make sure that you don't have the extraneous solutions, right? Answers that don't work. So all right, when we square it, I get 12 minus n equals to n squared. Remember, you want to set this equal to 0, right? You want to set this equal to 0. So I'm going to move my negative n to this side. I'm going to move my positive 12 over to this side, okay? I'm moving those things over. So we'll add n. So that's 12 equals to n squared plus n. And then we'll subtract 12. Again, you don't have to show me this work if you don't want to. Just, take it at your own pace, okay? So 0 is equal to n squared plus n minus 12. And now x method, and then check your answers, right? So what does this factor into? Can anybody, without the x method, can anybody tell me by guessing and checking? We'll do the x method just so you can see it. But what numbers for 12 can give you a 1, a 3, and a 4? So let me put 3 and a 4. Which one should I make negative? So if I make the 4 negative, what's negative 4 plus 3? Negative 1. So that's actually not good. It has to be a positive 1. So it's actually plus 4 minus 3. This is the way I learned to do it. My teachers used to say, well, think of all the factors for that number at the very end. So 12, okay, 12 has the factors of 1 and 12, 2 and 6, 3 and 4. And then my teacher said, well, the way you figure out which numbers to use 99% of the time. Let me just show you this really quick. You don't have to learn it right now, but maybe you might like this. Those are the factors of 12, right? Notice I did them in order. I started with 1, and I said 1 times 12. Then I went to 2, 2 times 6. Then I went to 3, 3 times 4. And then there's no more, okay? She would tell me, The way you know which ones are probably going to work, okay, are the ones that have the smallest difference. In other words, subtract the number. So 12 minus 1, that's 11. 6 minus 2, that's 4. 4 minus 3, 1. So which one has the smallest difference? 3 and 4. Most likely that's going to work. And look, 3 and 4 work. I just got to pick the right signs, right? Whatever makes it a positive 1. Okay, so I say, oh, positive 4 minus 3, that's positive 1. All right, now, this is the way I learned it, guess and check. I'll do it a couple times here, so in case you like it, you're like, oh, I hate doing the X method. What's another faster way? Just to show you, okay? But let's do the X method. I'm going to do it over here to the right side. So X method, this is a negative 12, a positive 1, right? Because A times C, that's negative 12. B is positive 1. I want to use a negative 3 and a positive 4. So this gives me n minus 3, n plus 4. Notice that's exactly what we got, right? The reason why I prefer guess and check, because it's more of a puzzle. So for me, I love puzzles, solving things. This is why I think math attracts me, is because I get to solve stuff. Something's unsolved, I got to figure it out, right? So I'm a big puzzle person. So I know during the pandemic, I don't know how many 3,000 piece puzzles I did, because to me that's fun, even though it's kind of boring sometimes. But figuring stuff out, right? I did tons of those things because, I mean, number one, I couldn't leave the house for a while, so I had to do something. But yeah, that took a lot of my time. But puzzle solving is my favorite thing. That's why I prefer guess and check versus X method. Plus, the X method didn't exist back then. I'm that old. They didn't really have that. So let's go ahead and solve. Whoops. N minus 3 equal to 0. N plus 4 equal to 0. So for the first one, n is going to be equal to 3. And the other one, n will be negative 4. The question is, do they both work? So if I plug in a 3 into my original equation, okay, if I plug in a 3 into my original equation, does it come out true? What does it come out to? 3 equals 3, right? Because 12 minus 3 is 9. Square root of 9 is 3. And then the other side would say 3, so 3 equals 3. Perfect. What if I plug in a negative 4? No, it doesn't work, right? So my only answer is this. This one is extraneous. Okay? That's an extraneous solution. It is a solution, it just doesn't work. So, all right, we got a couple more of these because there's different variations that you're going to see. Notice the first one that we did had a square root equal to a variable. This next one has a square root equal to a number. These are usually easier. I don't know why I decided to do it second, but whatever. We're going to do the same thing. Isolate your square root. Square everything, right? So it's already isolated. So let's go ahead and square everything. Square root of b minus 5 squared is equal to 10 squared. So the square root of b minus 5 is just b minus 5. And 10 squared is 100. Okay. And if I add 5 to both sides, I get b equal to 105. Now I got to check it, right? Because that's my answer. That was quick, right? No need for X methods here. If I plug in 105, does it result in 10 equal to 10? Yeah, it does, because 105 minus 5 is 100. The square root of 100 is 10. So it says 10 equals 10. So this is good. This is a good answer. Okay? All right. Moving along. By the way, any questions on that one? Or the previous one? I probably should have asked for that one too. So this one, a 21, I think was easier just because there's no variable on the other side. That's when it kind of gets a little bit tricky. And then this one right here did have a variable on the other side. So you end up with trinomials. You got to use the X method, right? Or guess and check, whatever you prefer. And if anybody here use the box method? I got to have you show that to me because I've seen it a couple times. I've looked at it. And sometimes it's still confusing me. So if you can, and once we're done, I'm going to have you do one. I just want to see it. So I got to process it. It's never made sense to me. I've used it for multiplication. That like for you know, when you distribute using the box method makes total sense to me. For some reason, factoring doesn't always hit me right. So I gotta see someone who does it consistently so I can see it. All right, same thing here. Isolate your square roots. Well, they're both isolated, right? So I'm just gonna square both of them. Now these may look like they're gonna be difficult, but the nice thing about these is that since both things are in square roots, when I square them, the square roots will disappear, and notice none of the terms will be squared. There won't be a 2x squared, no 5x squared. That won't exist. It's just going to be 2x minus 6 equal to 5x minus 15, which means you do not have to factor using the x method, right? Or a box method or guess and check method, whatever you want. So all I got to do is combine my terms and then solve. So let's subtract 2x. So this is negative 6 equals to 3x minus 15. I'll add 15 to both sides. So if I add 15 to negative 6, it comes out to, I'm going to put it over here, 9 equal to 3x. And if I divide both sides by 3, x is equal to 3. And then I got to check. Right? Because maybe, yeah, this is an answer, but maybe it doesn't work. Well, let's see. If I plug in a 3 into the left side, 2 times x minus 6. If I plug it in there, 2 times 3 minus 6 is 0, right? 6 minus 6 is 0. If I plug it in the right side, 5 times 3 minus 15 is also 0. Because 5 times 3 is 15, 15 minus 15 is 0. So it comes out to 0 equals 0 when I plug in a 3. So that's fine. The answer works. Okay? When you check your work, you don't have to show it. Just run through it. If you need to write it down, feel free to write it down. If that kind of ensures you that you're doing it right. Okay? If you can do it in your head, do it in your head. All right. Last one here. And I'm a little surprised that I didn't do one that would have like an n minus 5 on one side. Maybe the quiz doesn't have one. I'll look. Like I said, I'll look today before you guys leave so we can check. Okay? All right. What do I do first here? Do I add 8 or divide by, well, yeah, should I add 8 or divide by negative 8? Divide, right? I know it says minus 8, but what's the negative 8 doing to the root? It's multiplying it, right? It's not adding or subtracting it. I would add 8 if it looked like this. If that's what it looked like, notice negative 8 and then it's adding something, right? I would get rid of the negative 8 by adding it right there. But since it's multiplying it, then I got to do the opposite of it, right? So it's multiplying a negative 8. So let's divide by a negative 8. Okay. Yeah, those are always a little tricky. There's a lot of students that this type of problem will catch with addition. And I see it. I understand why you do it because it looks like, hey, every time I see this, I always tend to add it. But make sure you always ask yourself what's happening with that negative 8 according to that radical, right? If it's multiplying, then make sure you divide. If it's subtracting it, then go ahead and add it, right? But this one is multiplying. So we have a square root of x minus 5 is equal to 2. And now I've isolated my square root, so let's go ahead and square everything. So square root of x minus 5 squared is equal to 2 squared. So x minus 5 is equal to 4. Now add 5 to both sides. So x is equal to 9. So I'm going to put a box around it, but I am going to check it. Okay, I'm not just going to say I'm done. Okay, let's check my answer. So if I plug in a 9 into the original square root, it becomes 9 minus 5. That's a 4. The square root of 4 is 2, and 2 times negative 8 is negative 16. So it does work out. Okay. Again, if you want to work it out all the way through, feel free. I recommend it. It's good practice. Okay. But if you just want to do it in your head, that's okay. You won't have to check it on the test per se. You're not going to have to show me work that you checked it. But I'll know whether or not you checked it if you give me two answers and only one of them is actually an answer, right? Then I know you never bothered checking it. Or if you did check it, you may have gotten it incorrect. So, but that's it. You guys have any questions on any of these problems from today? If you do, let me know. I will look at your test to check to see if there's any square roots that are a little bit tougher than that. What was the other thing I was going to check? Oh, to see if they changed around anything with the negative powers. So I'll look through that.